So, hello everybody. My name is Emmanuel Frécon. I work for the SIX, Swedish Institute of Computer Science. I'm going to try to present something called Docker machinery, which is a command line tool I've been developing at SIX. And this is basically more or less intended for technical audience. You will see, as you've seen in the presentation before, some kind of terminal commands on the screen. Don't get scared. We all do this, don't we? So I thought I would try to, this is my kind of trying to present Docker in one slide to the people I'm trying to convince that Docker is good. So who's been running Docker? Everybody, thanks. Who's been running Compose? Okay, lots of you. Machine? Swarm? Yeah. So containers, you all know that. Compose is a way of getting them together to do something. Machine is a way to create the virtual machines you want to run your Docker containers on. Actually, you can actually even link bare metal if you want. And Swarm is a way to address the whole cluster from one place. Yeah. And machinery is kind of trying to do more or less the same as Swarm is doing, but controlling everything, including the creation of the machine. So if you think that Compose is composing all your containers together to put them together, think about machinery as the same way of composing or tightening together all your machines into one file, one place. And it has a command line focus, but there is some kind of web API, so that you can automate things. And it will allow you to manage the lifecycle of the multiple machines you will have in your cluster. So you will be able to preparate them, to put your images on them, to run the containers, to even actually declare the registries you're going to use if you use external registries or local registries, and to kind of initiate them. So if you've been running on top of something like Azure or something, you can, for example, once you've created the machines, there might be things you want to be doing on the machine once you've done it, once you've created the machine, and you can automate this from the same place. It kind of does some kind of discovery, but you shouldn't be reusing this. And it integrates Swarm and Compose. So, sorry, I'm trying to cope with everything. So let's start with an easy one. It's a YAML format. So if you've been running Compose, you will recognize that YAML is good as composing. There's a few things which are very good with YAML. For example, this one is actually one of the things I like. You create an anchor for if you've got some kind of worker machine that you want to replicate 10 times. You create an anchor once, and then the next time you're going to be just write one line for getting exactly the same machine, hopefully on the same cloud. Machinery has support for plenty of different providers. Basically, it relies on machine because machine has plenty of support for plenty of different providers. And to be frank, I haven't tested all of them because, well, they cost money. That's as simple as that. But at least I can prove I've been running on Azure. What I can say I've done. And I've been running on VirtualBox as well because that one is almost free. And you see that when you declare your machines, and which is basically going to be your cluster, you can specify sizes, or you can dimension them, and you can see here, you can integrate. This is integrating Swarm. So by just saying this is going to be your Swarm, the machine that will be running your Swarm master. You can provide metadata for all the machines you create, and this is going to be important when you run Swarm on top of them, because you want to be able to, I don't know, run on some machines you need an SSD drive, and you would be tagging this as this machine as an SSD drive, and on some other machines it would be different things. And these are all the labels. If you use Docker machine before, you will see that actually there actually will be labels in the machines as well afterwards. So this is very, very quick, but the command line syntax is basically the same as Docker, more or less. you have it's stopped by machinery, and you have got some global options for the rule of machinery. Then you have the command you want to start, say help, and then you have the arguments for the command afterwards. So that would be, it's a very dumb comment, but machinery, please give me some debugging information, which is completely stupid, and give me some help afterwards. That was just to give some kind of idea of what it does. So what can you do with this big YAML file you will have if you talk about clusters? This YAML file would be actually kind of long. It has some kind of basically a vocabulary which is very similar to Vagrant if you've been running this before. It's more or less also very similar to Compose as well. So basically up to start up one machine or the whole cluster. So basically if you say machinery up, this is basically, please bring me all those machines I've got in my LAMP file, and you will take 1, 2, 3, 4, perhaps 5 cups of coffee before your cluster is open. But it will be running in the end. And to turn down the machines, you have halt, and you can destroy the machines completely if you want, and you can restore the machines if you need to. There are some kind of aliases, so if you are a bit stupid like me, halt, you can say down as well too, because shut down. So automatically when you create your machines, they are basically the YAML file. So machinery looks for the one and only YAML file that's got one hash Docker machinery at the very beginning of the file into the directory. And the name of the file will be automatically added to the name of all the machines that you create. So in that case, you see in this example, I've got 2 clusters from the same command line and from the same place. One of them is called nbook3, which is one project I've been running on. And the other one is called Tyrants, because I've been having a project with this company. So this is basically all the machines that were created for these 2 clusters. So I can actually, hold on. You don't want to have the other ones, because that was basically, so this is what machine, Docker machine would be saying. So if you would be Docker machine ls, you would get this very long list. Since you run from machinery from one single place, what you want to kind of have a look at is this one, which is the small, that's your cluster when you're looking into it, when you're in this directory instead. Sorry. So it integrates with Swarm. The only really interesting part is basically it's got machinery Swarm. And by saying machinery Swarm, basically it will connect automatically to the master, because you have a master in your YAML file. If you just say machinery Swarm, that will list the Swarm content, which is basically the machines which are in your cluster, the active machines in your cluster. But you can also schedule compose project onto the cluster, so you can create containers or delete containers and so on. And this will be done by basically scheduling compose files onto the cluster. So if you've been running, some of you at least have been, machine on compose and Swarm, you send big compose file to Swarm, and basically this will create the containers on all the different machines that are actually relevant. Depending on the some will be spread, some will be and depending they will be using the roles and the labels. So that's basically up to your compose file to actually do the job. So this is basically the interface to Swarm. Sometimes you want, yeah, I'm not going to get into the details. Otherwise, we are here tomorrow. It does some kind of discovery, and it really does it actually kind of badly, but. So, it extends the compose syntax. So what it does is actually basically that since from a single place I've got a list of all the machines in my cluster, I also know their IP address. So basically it will automatically declare environment variables which will be called machinery underscore the name of the machine underscore IP or host name, for example. And those environment variables, you will be able to use them for, in your compose files, to look for things you've been placing to the right or to the left. It's actually very bad because if you restart machines, they will change IP address. And if you add containers depending on those IP address, well, you are in you will be having problems. So basically, what you should really use this is basically, for example, just to initiate your real discovery using console or whatever you want, to just for the first machines that will hopefully not change very much. And then you should use something else. This is just for initiating things. It's not something you really want to use. Docker 1.9 has a new networking interface, and this actually reduces the use for this, because the new networking will allow you to address the containers using some kind of overlay network on top of your whole cluster. I did this before. Very quickly, you can introspect your cluster. You can PS, please give me all the list of all the containers, and that's going to ask the swarm master, please give me all the containers running right now. You can ls, which is what you saw before, give me the list of all the machines I've got in my cluster. Or you could search for matching containers in the cluster, and that would be give me all the, I don't know, the workers in mine. If all your workers have the kind of the same name, and you would get in the end a list of where they are, on which machine they are running. This is the ls summary. We've seen this before. You can do things. You can get a command prompt into one machine, or into a container. That's actually very easy from time to time. And you can also, for example, execute one Docker command on all matching containers. So say you have a bunch of Nginx running into your cluster, and you want to restart all of them because you have some kind of big problem, I guess. You could say machinery for all the Nginx's, which are, I suppose you've got some naming here. Star will match anything and restart. And this would only restrict to only on the workers. If you've been naming all your workers something WK, it's based on conventions in your cluster. We've seen before at the very beginning a very easy YAML file. That's the easy part, just creating all the machines and do all the work yourself, or run something else. But there are plenty of things you can. There are plenty of different sections in this YAML file for when you describe your machines. For example, you can compose directly on the machines. That would be not through the swarm. That would be directly on the machine. And the kind of things you can use this for example, is running one. If you want to run one container for capturing all the logs of all the containers on each machine of your cluster, for example, and sends all of those logs to a central place, for example, that would be a good way of doing this. This addendum is what I was talking about before. Is basically once you've created on your machine and you've done everything, please run this command, whatever that command will be. You can prepare all your images. So the idea with this is really some kind of security ID. If you've got a private registry, you ensure that the machine that is going to control the whole cluster has access to this registry, and the images will be directly put onto the machines in your cluster, so that your containers will be able to run from those images. So they don't need to access the registries. So you don't need to have one registry central that all your machines need to be able to access. You just transfer them at once using SSH, so they are actually encrypted on the way. If you don't want to do this, you can specify the registries you want. You will be getting your containers from. You can open ports, and that is basically, this is used for when you run VirtualBox. That's going to be doing some port mapping. And you can create shares, and the real use of this, except if you want to double. So if you are running a VirtualBox cluster, So if you want to mount a directory which is local in your host onto your virtual machines, which you will be then mounting onto your containers. So this is one way of doing this. So that would be mounting your local directory onto, if you run VirtualBox, onto the virtual machines, and then it's up to you to actually mount this again onto the containers. But the second one, which can be useful anyway, that if you declare things in shares, you will be able to do some kind, to run a command called machinery sync, which is be able to fetch the content of the virtual machines hosting the disk it has back to your central place. So that's kind of backup idea. So all the virtual machines that you've been creating, if you've declared the shares properly, you just do machinery sync, and from time to time using a cron job or something, and you will be from time to time getting a snapshot of what's on the virtual machine. So if you've got problems, so if the machine dies, which it will probably do after a while, because there are always problems, then you hopefully have some kind of backup. It's not done for doing some kind of very nifty, NFS or EFS or one of those, or Gluster FS. So it's not. That is basically backup. So what I've been using this for, I'm not going to go into the details of this, I promise. But what I do is research in the Internet of Things. So I'm running. I've been running actually clusters on top of VirtualBox for real, because in research it's actually much easier to buy a server. You buy it once. Compared to, I don't know, buying some hosting on AWS or something, and you never know how much you're going to pay. We don't like those. So I'm using VirtualBox as a way of simulating if I had a real cloud somewhere. But I've been also running on top of Azure. This is just to explain that basically that's I can go into the details at the pause if you want, what I've been using this for. So machinery is, it works, it comes from my needs, because basically I wanted to create plenty of Docker machines, and there was no way to create those Docker machines. So I constructed something that would automate the creation of all the Docker machines for me. I've been using it for a number of clusters. It's used my needs, but it can be, the list of things I can think of is kind of very long. I haven't tested all the drivers and the providers of virtual machines. AWS, I haven't tested. Google Cloud Engine, the list is kind of 10 or 15 long. Currently, it's basically you have to fetch the binary and run the binary yourself. People are actually kind of okay doing this. It is basically the way you install Docker if you want, or machine, or compose. But it would be actually very nice to be able to actually run Docker machinery in the container instead. That container would be running in privileged mode, though, I guess. I haven't done this yet, but Docker 1.9, well, 1.0, yeah, has some kind of networking and overlay networking, which is ready for almost prime time. It's not encrypted yet, so it's kind of ready from prime time, but not really. And it has support for volumes, and it's probably a very good idea to integrate this in machinery and declare your volumes and declare your networks and use those networks in your machines. There is a web API for machinery, which is done for automating everything. The web API and the command line API are not completely on par, so I need to do this, which I haven't done. On the same kind of idea, kind of this, I would like to have some kind of, inspect or something like, which returns some kind of JSON when you do your comments. Or give me the list of my machines, and you would get JSON back. And the idea with this is, if you do this, you could actually automate machinery from something else. That's just the whole purpose of this. Currently, all the machines are created sequentially, which isn't very good. I'd like to be able to create those in parallel. It's actually kind of good to actually create things sequentially, because if you have machines dependent on one another, it's actually good in some situations. So I would like to be able to actually cover actually both cases. Yeah, there is a list of, the project is on GitHub, and there is a longer list of things to be done on GitHub. It's not coded in Go, and everybody codes in Go, so yeah. Yeah, the only one interesting one, I've got plenty of different things on GitHub, but the only interesting one is this one. I just took the slide from something else. But that's where machinery lives. Please test it, help me debugging it, use it, you're welcome. Hack in it if you want, fork it, whatever. I would be pleased. I would be happy. So, questions?